Another common aspect of charges is that they can apply force. So this has been understood and it's in the form of a law, and that law is called as Coulomb's law. So the observation is that the force between charges, they are dependent on how strong the charges are and how far apart they are. Officially, we need to write in this manner. That is the magnitude of electrostatic force between two charges. It can be in the form of attraction or repulsion. It's directly proportional to the magnitude of the charges, the product of the magnitude of the charges. That is, it is Q1, Q2. And inversely proportional to the square of the distance. Inversely proportional to the square of the distance. Where have you seen this? Yes, it looks similar to your gravitational chapter. So this is nothing but your inverse square law. The force acts along the straight line joining them. Well, what does that mean, and how does all of this look mathematically? So we have two charges over here, Q1 and Q2. The distance between them is R. And in this case, it's important for us to understand that this is vacuum. Why? Well, when we take up the proportionality constant, or it's observed in nature that the medium which the charges are in, it does affect them. Unlike gravity we have seen doesn't matter wherever it is, what medium it is in. That is, let me put it in a more simplest manner. If I keep two charges in water, the amount of attraction, it's not the same as when we keep it in vacuum. As simple as that. So this is what? Medium dependent. Medium dependent. Okay. And these are your amount of charge. And that's your distance. Magnitude of charge. And that's your distance. Okay. So with this, we can define the unit of charge. That is to define 1 coulomb of charge. Say we have two charges, they are said to be 1 coulomb. When they are kept 1 meter apart, again we are trying to define two charges or a charge which is said to be 1 coulomb. Say we have two charges which are 1 coulomb and they are 1 meter apart and they are kept in vacuum. So when this happens, let's see what happens with the force. Force is equal to K times of 1 into 1 by 1. So basically, F is equal to K. And this constant turns out to be 9 into 10 to the power of 9 newtons. Okay, so we can put it in this way. Say we have two charges. We don't know what is their charge per se. We don't know what is the X. In this case, X is this. How much coulomb? We don't know. But we know that both the charges are of same nature and same magnitude. The strength is the same. And they are 1 meter apart and they are in vacuum. And if we observe that the force acted on Q1 by Q2 or on Q2 by Q1, the amount of force, if it's equal to this, then by default, both the charges has to be 1 coulomb. Okay. So 1 coulomb is defined as the quantity of charge which when placed at a distance of 1 meter in air or vacuum from an equivalent similar charge. If they experience a repulsion of 9 into 10 to the power of 9 Newton, then they are said to be 1 coulomb of charge. Right? That's all. So whenever you have to define anything, whatever variables you guys get to handle, right? Whatever variables that you can get to change, make that as 1 and see what the LHS will result in. And with that result, you can define whatever the quantity is. That's the thumb rule for your defining quantities. Now, we know that forces are vector quantities, that it is we need to have the directional aspect. So it's quite confusing over here, like gravity, similar to gravity. It's important for us to know the sequence of writing. What I mean is, when I write R21 over here, right, which I've written over here, that is the arrow is moving from 1 to 2. Okay, from 10th grade you have written this, mu AB. What is this? Yes, your refractive index and all that. So basically the sequence in which things are acting and the vectorial representation, it's important, right? So it's always to from. That is, if I write R21, the vector is moving from 1 to 2. So now same charge 1 and charge 2, charge 1 and charge 2. So they are positioned at some point whose coordinate is given by position vector R1 and R2. So the displacement vector from 1 to 2 is given by R21. Again, you guys have to be very thorough with vectors. It should be very natural. So this you should be able to understand very easily. If not, please study vector topic. Now, how do you represent force? Well, if I write F21, that is because of 1, how much force is exerted on 2. It's given by, so we're looking at vector form, K, Q1, Q2 divided by R square. All these are scalar quantities. So we need to write the unit vector. And this makes it a vector quantity now. So R21 is nothing but unit vector pointing in the direction of, well, from 1 to 2. Basically, it will be something like this. Right? Okay. So we need to understand that this formula will be able to handle all the scenarios. When charges are positive and positive, what happens? Well, when both are positive, they will push each other, is it not? Okay, so this is Q2, this is Q1, while R21, the unit vector, will be in same direction as F21. And remember, this is F12, right? F12 is nothing but the force exerted on 1 by 2. So when we look at this, F21 is positive, telling that it's in same direction as R21, right? What if the charge are opposite, like positive and negative? So if they are, so what happens? The force is attractive, right? And the unit vector is clearly opposite to that of F21. And here F21 will be negative, which implies that the directions of the unit vector and F21 are opposite, same direction, and this is in opposite direction as our R21. Okay, so basically, if you guys look at two charges which are positive and negative, obviously positive into negative is negative, positive into positive is positive. What about negative into negative? Same funda, right? So we have two charges which are both negative. What happens? Well, they will repel each other. This is Q2 and this is Q1. And that's your line that connects the centers. So our unit vector is in this manner. So that's our F21. So clearly we can see that they're in the same direction. So positive, this indicates that It's in same direction as R21. So what we are trying to tell over here is that the formula takes care of directions, all possibilities, right? Okay, done. One last set of information. This particular formula, whatever we studied, it's valid for range from minus 10 to the power of, sorry, not minus, 10 to the power of minus 15 to 10 to the power of 80. That's a fact that you guys have to know. Over and above and below this, or sorry, below and above this actually, things are not the same. Now, what is that we studied? Well, we studied that charges can exert force, right? We know that. Now, how much force? It's given by your Coulomb's law. So mathematically, we have it to be F is equal to K times of Q1, Q2 by R square, where K is your medium dependent value, the proportionality constant. Q1, Q2 are your charges, and we have the distance. Till here, it should be okay. So yes, you guys need to write the statement as well. And we learned to define 1 coulomb, quite simple. We have two charges. We just know that they are same value. They are the same magnitude of charge. And we know that they are in vacuum and that they have a distance of 1 meter. If the force that is exerted on one charge because of the other charge, if it's equal to 9 to the power of 9 Newton, it's a huge charge, then the charge is said to be of 1 coulomb value. And yes, we need to understand the vectorial representation of, well, any force. So in this case, it's quite simple. Whatever the direction the unit vector is, if it's in the same direction, then it's repulsive. If not, it's attractive. And the formula takes care by showing that the result is positive if they are repelling, it's negative if they're attracting. And the sequence in which we have to write, that's pretty important. It depends on book to book. If you guys are reading different books, if the representation is different, it's just that they are using a different representation. So it's left to the authors. Okay, guys, don't think too much. Whatever is your textbook talking about, just stick to that. Right? And finally, we have the range value. Anyways, so this is something you guys have to write.